Okay, now in this video, we want to again work along with our PowerPoint presentation and Desmos files to discuss the hyperbolas whose center is no longer at the origin. Okay, so we now have hyperbolas, okay, whose center is at some point h comma k. And as you can see here, the equation is very much resembles that of a circle whose center has been shifted. So, and it's very much the same line of reasonings here. So, everything is going to follow accordingly with that translation in H horizontally and K vertically. Okay, so let's take a look at the Desmos file created to work along with this. Okay, it's down here somewhere, I believe. Here we are. Okay, so here we are with the Desmos file. All right, pull this in the center. Okay, we can decide where our center is going to be. Okay, so I guess maybe for convenience sake, we'll keep it at the origin for initially, just so you can see is everything is pretty much the same as it was before. Now, let's say we want to move to our let's go to let's go to 3 -2. Okay, 3 -2 of our center now. Okay, so here we are, and now of course we can adjust the A and B values as we have previously. Okay, and all things remain the same. Okay, the big difference is you have to remember this has been translated. So A and B are going to remain the same. Okay, what's going to change is pretty much just your the coordinates of your focus point and the asymptote lines here. Okay, the C value is still going to be determined to be the same, but of course the C value here, with this orientation opening up left and right, the C value is giving coordinates which are relative to the center here, relative to the center. So the center is right there, and our coordinates of the C value are right here. Let me just this got shifted a little bit, so I'm going to put that right back to -2. Okay, so as you can see here, okay, our C value is as computed here. So this value is, okay, having the same y coordinate, as you can see, because of its orientation, but the x coordinate of the C is the C value taken from the x coordinate of the center point. And likewise here, maybe a little easier to see, since the C is 2.44, we add that to the 3, okay, and there we have it as the coordinate of the foci there. Okay, maybe changing A and B to be a little bit more convenient, like 3 and 4, maybe we could see that a little bit easier. So let's see, we'll go to that. Okay, because then we'll see a nice Pythagorean triplet. Okay, so here we go. So the C value is 5. So 5 units to the left of the center is the focus, and 5 units to the right of the center is the focus. Okay, had this been oriented in the vertical direction, of course the focus would be altering the y value, keeping the same x coordinate. Okay, as was the case, as was opposite the case here. Okay, the slopes of these lines, the slope of these asymptote lines remains the same, as you can see, B over A, but the it's just a modified equation, because no longer is no longer do the asymptote lines contain the origin, but they contain the point here, -3, -2, which is the center. So we keep the equations of the asymptote lines with the same slope formulation, but we use the HK value. So we get that form for our equation of the asymptote line. So we go back and we'll take a look at this right here. So there it is. Okay. We have those coordinates the same. Okay, we have the asymptote lines defined with the H and K values in place, and we'll look at some specific examples in the slides to follow. Okay, so this is the equation for the hyperbola. Okay, oriented. Well, the equation could be the same oriented regardless of the orientation. The emphasis here was with the repositioning of the center to H and K. You should reason this out the same way if the orientation was vertically, okay? In which case it would read, y minus k, the quantity squared over a squared minus x minus h quantity squared over a squared, okay? You should try that for yourself.